Here's our Kilroy board version 2.0 that we're going to work on soldering today. Here's the front and the back. The back is where all the soldering will occur, and the front is where all the components will be attached. Notice that certain components have already been soldered in place, like the chip here, a few capacitors and resistors, and the micro USB port. The first components we're going to place are the female and male headers. Here's the 8-pin female headers, the 6-pin female headers, and then eventually we'll place 3 male headers for the servos and for some other settings. So we're going to start by doing the 8-pin headers, and they're going to go here on the front side of the board. So we're going to stick them in. Make sure they're pressed completely flat to the board. Turn the board over, and then you can use a pair of needle nose pliers to gently, slightly bend the opposing pins, one forward and one backwards, so it doesn't fall out as much. And then that'll leave you to be able to solder these joints here. Here's the soldering iron. Here's the soldering iron. Remember to clean off the tip to get all the black residue off of it and make sure it's got a nice shiny surface. And then clean it off on the sponge and add more solder to the surface to tin the tip so it's nice and ready to be used. I'm going to start by soldering the first 2 pins I bent down. Remember, the steps are: 1, place the soldering iron on the board; 2, feed the solder in between the soldering iron and the connection; 3, pull the solder away; 4, draw the soldering iron away up the stem of the component. So 1, 2, 3, 4. And when you get, we're starting on these easy components that you're not going to damage too much with too much heat, so that when you get good to more difficult components, you can do it in under 4 seconds. So I'll do the other side. 1, 2, 3, 4. And I'll just zigzag back and forth to limit the amount of heat in one area. I'll continue to do all the connections until they're all done. Once you've completed the one side, you can go ahead and solder the female headers in place. I'll go ahead and stick both of them in at the same time and then solder them, making sure to keep it flat, and so that the boards are sitting flat on the surface, and they're all in a line. One, 2, 3. Alright, since I messed that one up, I couldn't get the solder to melt. I'm going to stop working on that one for a while to let the heat dissipate, and I'll work on another one. There, now they're all soldered, and once again, no solder is between any of the connections. If you do get too much solder in between the connections, you'll have to remove it with either the desoldering tool or soldering wick, which you can ask your instructor about. The next piece I'm going to solder is the male headers, the little 3-pin pieces, and they're going to go where it says servos. Stick them in there, hold them in place as I turn it over. Might take more than one try. following the same soldering procedure as before. We'll do the outside first and then the inside. And I'll do the other one. By doing these all on a flat surface and doing all the header pins first, they'll be able to sit flat and it makes it easier to solder them. Now that we've done the headers and we've gotten some solder practice, next we'll do the resistors, which are still not so sensitive. We're going to solder 4 resistors in. 2 330 ohm resistors, which is orange, brown, at R4 and R5. And then 2 4.7K ohm resistors at R9 and R8. And I'll go ahead and put this in place and then bend the leads. Once you get the component in place, it would be helpful to bend the leads to about 45 degrees so they don't fall out. It might make it easier to place the components by using a pair of needle nose pliers to bend the resistors down at the ends. So this is R5. Again, a 330 ohm resistor, orange, brown. And if you need help, you can use a pair of needle nose pliers to gently pull the resistor lead through the board so the resistors sit flush on the board and aren't at an angle. Once I'm done placing all the resistors, I can go ahead and solder them in place. Still trying to stay within the 4-second limit. One, 2, 3, 4. Draw up the lead. That might need a little solder on it, but I'll wait and come back later and get that after it cools off. Let me reposition so you can see better. Every once in a while, it's a good idea to clean off your soldering iron on your wet sponge. After you're done soldering all 4 resistors, you may use a pair of diagonal cutters and snip the leads right above the solder joint. Another tool that works well is toenail clippers. Make sure not to damage any other components or solder spots on the board when clipping leads. The next 2 components we'll work on is the small slide switch that'll turn our Kilroy board on and off, and the power diode that'll allow it not to be power to go the wrong direction. The slide switch will go here where these 3 spots are, and the diode will go here at D1, making sure to face the silver band in the same alignment as in the graphic. Now we have the switch and the diode in place. So I'll go ahead and solder it, making sure to keep the switch flush to the board. You have to be very careful not to heat the switch too much, because the plastic underneath the switch housing will melt. Once complete soldering, you can snip the leads of the diodes off. Next, we'll do the socket for the pickaxe chip. We're going to use the socket so as not to damage the chip, and we can change the chip in and out if it gets damaged in use. So I'll place the socket here on the board. And it may be helpful once again to use a small pair of needle nose pliers to slightly, gently bend the opposing pins up and down out of the way so it holds the socket in a little better. Making sure not to scratch the surface of the board. After I have my socket in place, before I solder, I'm going to make sure the socket is completely flat. If it's helpful, you can rest the socket on something while soldering it so it's the lowest thing on the board. As you solder the socket, it's a good idea to go back and forth so the heat doesn't build up in one spot too often. After finished soldering all the socket connectors, make sure all the solder joints are clean, and turn it over and make sure the socket is still flush to the board. Now we'll solder the capacitors in place. We have a 0.01 microfarad capacitor, which is C1. We have a 100 microfarad capacitor, which is C2. We have a 220 microfarad capacitor, which is C3. And then we have a 1 microfarad capacitor, which is C5. Your C1 may be slightly different. It may be green or a brown color. Now that I have C1 in place, I'm going to place C2. C2 is the 100 microfarad capacitor. This C1 is non-electrolytic and has no positive or negative. C2 does have a positive. It's indicated by the small little plus on one side of the capacitor. That will go the opposite side of the gray line, which signifies negative. Now that we have all 4 capacitors in place, we can work on soldering them. I'm going to alternate soldering different capacitors, again, just to worry about the heat. Clean your soldering iron off every once in a while. As you're soldering the capacitor leads, if it makes it easier to snip them off after you're done, you can do that to clear them out of the way to reach some of the other leads. Now that we have the capacitors done, we'll do the LEDs next. We'll do the red LED for the power here in the middle, making sure to notice that the flat line indicates negative on the graphic, and the yellow LED as the status LED here on the side. As you place the red LED, make sure to put the flat side of the LED in line with the flat part of the graphic. On the status LED, it doesn't give you a flat side, but the flat side of the LED faces towards the inside of the board. So there's the flat side right here. I'll put that towards the inside of the board. Now that I have the LEDs in place, I'll solder them. It's crucial to make sure you have a nice clean soldering iron tip and you are able to solder the LEDs fairly quickly. So I'll alternate where I'm soldering to save heat. When they're done, you can clip them off, making sure not to shoot them in your partner in the eye with the leads. After you solder everything else on your board, you'll need to solder your voltage regulator, your power jack, and a jumper into R3. To solder the voltage regulator, you need to bend the legs first using a pair of needle nose pliers. So bend the leads right at the base of where the wire size changes to about 90 degrees. And now they should be able to stick into the board, and then angle them down to solder in place. So solder the three components, the three leads in place. So they're nicely secured. Then you can turn it over and into the correct hole here. Once that is in place, you can turn it over again and solder it in place. When you solder the power jack into place, make sure you use enough solder to completely cover the pad, but not too much that it overflows. Remember, if you need to re-tin your soldering iron or stand off the tip a little bit so you get a better solder connection, to do that often. And to wet your soldering iron often to clean off the solder. Now you can see three nice solder joints on the power connection. To solder the jumper in place, use your needle nose pliers to bend the leads over and strip it on the ends so the middle insulation is only about a 1/4 inch long. Use the correct color that as instructed by your instructor. It goes in the spot where R3 would normally go. Like that. So you'll turn it over and solder it. When complete, use your diagonal cutters and snip off the leads.